Hello everyone, in the last few videos we have seen different functionalities in the linked list, like adding at the end, adding at the begin, adding at the given position, then remove from end, remove from begin, remove from given position, display function we have implemented. So everything is running here. So if I compile it, g++ node.cpp, then linklist.cpp and main.cpp, the program is running. I am getting the output for each and every function that I have implemented, but one thing is missing over here. Now what is missing thing in this linked list class? Suppose if I check for memory leakage in this program, so how to check for that? Valgrind is a tool, you know that. So if I say valgrind./a.out, then it is showing memory leakage in this program, definitely lost 40 bytes in 5 blocks. Now why this memory leakage is there? Because in the main function I will call different functionalities of the linked list, like add or remove functionality. So there may be some switch case here. In each case I will call the appropriate function. But now what happens when this L1 object goes out of scope? Now linked list is there are few nodes in the linked list, and L1 object goes out of scope when the main function is over. So when the main function is over, L1 object is destroyed. That means what is there in the L1 object? So L1 object has head inside that. So this head is destroyed, but linked list will still exist onto the heap, and there are nodes onto the heap which are not deleted ever. So that will cause the memory leakage. So what I need to do, before this L1 object goes out of scope, I have to delete each and every node of that linked list, and that thing I have to do inside the destructor of linked list. So missing thing over here which I need to implement is destructor for this class linked list. So this is the important function that you have to write to avoid the memory leakage. So I have to add this destructor in class linked list. So this is the declaration. Definition I will provide in linklist.cpp. So let me write the definition. Now what you will do in the destructor, now there is a difference between destructor and remove function. The remove function is removing a single node. However, destructor will destroy the whole linked list. That means destructor will delete each node starting from first to the last node. So let's write down the definition of destructor. So linked list, scope resolution, linked list. Now what I will do inside the destructor, so I have the linked list and head is pointing to that. So I am supposed to delete each and every node in the destructor. So I will take one trav pointer which will initially point to the first node. That means node asterisk trav equals to head. After that I will keep on deleting each node. So what I will do, I will move the head pointer. Say suppose I write here head not equals to null, and I will move the head pointer ahead. So I will say head equals to head arrow get next. So this is the first time I am moving the head pointer. Generally we do not move the head pointer, we take the trav pointer and we move the trav, but this is the first time I am moving the head pointer because now I don't need that linked list anymore. I want to destroy the linked list. So in this while loop head will go ahead, and when head goes ahead, I first delete the trav pointer. That means the previous node is deleted. So I have to do something like this. First it should be head equals to head arrow get next. So head will go to the next node, and then delete trav I have to do. So it should be here head equals to head arrow get next, and then delete trav. And after the trav is deleted, in the next iteration again trav should point to the head. So trav equals to head. So this thing should repeat. That means this while loop will keep on deleting the trav pointer, and trav pointer will follow the head pointer. So from first node to last node it will delete each and every node. Now let's see whether it is running. That means suppose if I compile this program, I run this program, then I will get the output. But now with Valgrind, am I getting memory leakage or no? So as of now I should not get any memory leakage. See, now the message here is all heap blocks were freed, no leaks are possible. So now there is no memory leakage. Earlier when I did not write the destructor function, there was memory leakage, and now when I write this destructor function, there is no memory leakage because before the L1 object goes out of scope, it will call the destructor automatically. So before this return 0, destructor will get called, and inside the definition of destructor I am deleting each and every node of that linked list. So this will be the definition of linked list, and now this is the complete implementation of single linked list. So from the next video onwards we'll be implementing doubly linked list. So keep watching my videos and do subscribe.